Hello, folks. Um, I have no idea how many of these short clips I've recorded since the last time I actually posted, and I don't know if I'm going to post this one just because it's one thing to record something, it's another thing to take the time to actually like go through it, edit it, and upload it, even if you do, try to do it quick and dirty like I do. It usually still takes a couple of hours, and I just don't always have that. So I'm going to try to make this a non-edited, very quick summary, and I want to let you guys know that I actually started over. I actually restarted the training completely from scratch, and I'm going to try to explain to you why. There are two things. One is when I actually looked at the heat map, I noticed specifically that some of the messages that we had been burning into, that the model was paying attention to, were messages that were part of the tutorial that is only shown on level 1. That means that the bot was basing its decision of whether to fire a gun based on whether it saw a tutorial message pop up that said press F to fire a gun, even though it doesn't know what F to fire a gun means. It just noticed that something good happens if you press F when that thing lights up. Same thing with the stairs, our magic stairs that we've been battling with for the last weeks. It turns out that to the extent that it was starting to recognize, dialogues around the stairs, it wasn't recognizing the like, whatever, there are stairs here, text on the top left. It was recognizing the stairs, press spacebar to descend dialogue on the top right, which is a tutorial message. So one change that we've made, let me see if I can show you some of the changes real quick. This will just be code changes. Fancy videos might follow later when things settle a little bit. We set up the environment to start retraining. That in this case means we have to train a new visual model. We literally start from scratch. So we do a couple of things. We enable a general exploration bonus again. Those are very helpful for CNNs to move to where they haven't been yet. We make shorter training runs because we want to make sure that we don't spend 5,000 turns just fumbling around. That means you can only lose points for 1,000 turns. There were a few other things, and this is a very important change. I also realized that the CNN, the way it was configured, was actually not providing enough granularity. Like, by the time that information was passed to the decision maker model, every 4 characters, a 4x4 grid on the map, had effectively been condensed into one blurry blob. And even though there are good reasons to do this thing called pooling, and we still will now do it, you have to be very careful with how you do it. So this max pool 2D actually kind of picks a random weight out of something that was at least 2 pixels next to each other, or 2 characters next to each other in our case, and then sends it up the chain. But that means that you lose the actual position, you lose the actual coordinate. And obviously, when you're playing NetHack or something, you need to know actually exactly where a given thing is, not some general sense that it's in a certain grid. So we fixed that by using a different method that is still using, it still creates higher level aggregates, but the idea now is that instead of max pool, we just stick with max conv. What this does is it creates larger fields of recognition. So we still see, in a way, every single character. Then we have a way for the model to look at larger fields of characters and recognize larger patterns, but the granularity of every single character isn't lost. The models have the chance to encode an understanding of every single coordinate in our grid into additional integers. So we don't lose that understanding, even though we are still producing also higher aggregates of understanding. I thought this would be much more expensive, but it turns out it's not. And I've been testing it, and frankly, the result is impressive. What else have I done? I've gone into the engine code, not into the engine code, but into the configuration itself, and removed the training dialogues. So this will just not be showing while my new model trains level 1. Then I made some changes so that we actually are running a new training on the CNN from scratch. And I went and deleted, everything, right? I went and deleted all my old files. Remove, 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 delete, delete, delete. But of course I have it backed up. So there still is, if I listen, if I ls, right, I still have my old model. I have my old data here from before. But as of the weekend, I am starting over from scratch, starting literally yesterday night with running. Now, how is that going? Actually, it's going shockingly well. This is the new model. This is the new model, which is not a long-term decision model. It's just a convolutional network again, but it's running in our better setup and with our environment that has been tweaked and tuned for the last month to try to get better results out of all models, right? And so actually, as I look at it, it has very quickly, like this is from the very beginning, it relatively quickly, after about 89 runs, it first made it to level 2. Previously, that took thousands of runs, right? And then it started hitting level 2 much, much more frequently. Then it started hitting level 3 on occasion, and level 26, our old friend. That's the one that was crashing the game earlier, or crashing my loop earlier, because it was waiting for me to hit yes, and it never actually returned. We even hit level 4, yeah? So this is very good. So this model is coming along very quickly, and I now understand much better what I'm looking for when I actually want to hook up the LSTM. I now want to look for a stable model where you can see right here, the explained variance here is 98%. The entropy loss is minus 294. I won't care that much about the entropy loss anymore, although I still want it to remain relatively high, but this explained variance is very important. I want the CNN to feel that it can explain the amount of points it gets for taking a given action to a precision of at least that amount, about 98%, but I want it to be able to do this reliably. And so I now have a new log that allows me to see this. And this is like keeping track of these little checkpoint windows that I was showing, but that I was always having trouble hanging on to. So I can see here that this explained variance is looking, already getting very high. This has only been 1 day of training. We've only done 600,000 or 6 million time steps. It's not a lot. It took 34 million time steps, I think, the first time, before we got to the first level clear. Of course, I was learning a lot about, setting the parameters. And we see here the explained variance. It's as I go back in time, it's not decreasing or increasing that linearly because it depends on what the model encounters. But very often now I'm definitely seeing above 90% already. The highest was that one at the bottom with 98%. And here we still have 91%. What I'll be looking for is a set of snapshots here that has on the order of 95% plus consistently for a significant number of snapshots. So I'll probably let it run. See here, we have one at only 86. So I'll still let this run a while longer because I want this vision system to be as kind of stable as possible. If you like, why don't we see very quickly what this new vision system is actually seeing? There we go. Oh. Okay. And we have our first bug. Give me a second. Okay, so we just made some bug fixes. Now, to be clear, the way this works now, it doesn't show us a more precise heat map. That would help us, but it doesn't actually help the AI. What the AI is doing is it's actually still taking chunks of the map and interpreting them. But what's happening is the CNN is interpreting some chunks of the map and then merging together useful information from those chunks of the map into an aggregate array of what it's paying attention to and what it's trying to say about it. We are not seeing all of the detail of what the CNN is trying to say about it. So in a way, I'm afraid this looks blurrier for us. But the reality is that this new setup is actually allowing the CNN to encode from each layer to the next more specific information about what's going on at each coordinate, so that that information is preserved, even though it's kind of like visually compressed. Now, one thing we see here, look, we see that something happens. It's noticing that a message popped up here. When the message wasn't there, there was no attention here. The message pops up, it turns yellow. This is the sort of thing we want to see right now. Yeah, we see that as that wall expanded, its focus shifted to over here from here. So as it saw that this passage exists, it's like, oh, I kind of want to go this way. We don't see like, we don't, so now it's kind of trying to decide between here and here. This is no longer relevant. This is no longer relevant. Now here things get interesting. We can never exactly see, because of the way that this is being diagrammed, we can never exactly see whether this guy is somewhere lighting up or being recognized. But we no longer have this thing here that says press F to fire. Instead, we have former human unhurt. This is normal, and this will continue to show even late in the game. The fact that the CNN is realizing that this is kind of important is good. It doesn't hurt us at all. The fact that this is lighting up, may also be good. And down here, the fact that it's noticed, actually, has it noticed that something's changing? Yeah, I don't know. So in general, it is noticing that there are things here that are good. Here's a good one. The missile hits. This lit up. We give the AI more points when we see the message the missile hits. We also give him more points when he gains XP. So he may have learned to associate, oh, I get more points with I see this dialogue, even though we don't give him the points for this message showing up. We give him the points for the fact that he's dealt more damage. But that's still good. And we still see that there's this grid of attention here. Yeah, with the AI, with our Doomguy basically looking to go this way. Yeah, okay, now he's got nothing left to do. His general attention is over here. And once again, we see the lively shifts here in the heat map. It is drawn vaguely, it is blurry. This is, like I said, this is on purpose. You can see brighter areas also where heat maps overlap. So what this is now doing is it's trying to produce an aggregate view of a certain set of quadrants and then zooming out and zooming out and zooming out from different points of the screen, and they overlap. And that gives the AI the ability to put together sort of a higher level analysis. I like the fact that I'm seeing glow over here. I'm gonna tell myself that this is because he's actually noticing that this guy is running around over here, because I have very little evidence of that ever being a thing. Let me see again if this is lighting up. Yeah, there's definitely a shade of red that shows up here. So it's definitely aware that these messages mean something. Here you go. Once again, if it does get stuck in the occasional menu, it's like, that's interesting. All right, he managed to shoot everything. He's got 28% health. It's not a lot. He just closed his own door. Okay, there you go. He's gonna go through, yes. Again, did anything really change in the attention mapping from before and after the door? Yeah, kind of. So he became more focused. When he got through the door and he clearly goes into the same space with the staircase, you can see that the rest of the map doesn't matter anymore, which is kind of good the way that is. Yeah, now he's going to stand here. And that was it. He's already down. That wasn't a lot of button mashing. He got to the next level, no problem. And he gets himself blown up, right? Oh! Somewhere he got full health back. Wait, when did he do that? This is amazing to me. Now I'm very curious. I'm like, when did he get the health? Did he? He dodges. Medpack. He used a med pack. He went in and he used a med pack. Yeah, so the model has figured out that sometimes combinations of keys that take you into the menu and back out are good for you. The long-term math on the model. But the CNN, while it's trying to make decisions, as I've explained many times, doesn't know that. Doesn't know exactly what it just did or why it's there. So the math of the long-term model will say, hey, every once in a while, like when you're low on health, sometimes good stuff happens if you hit this button that opens your inventory, right? But the chance of something good actually happening just depends on the model then getting lucky while it's in the inventory and doing something that actually looks like a health kit, for example. Now, there's a moderate ability to tie that stuff together as well. Okay, I think we've seen enough of this. I can say that the decision making that the model, even though this looks blurry still, right? That's just because it's a different kind of implementation. The decision making that the model is engaging in is definitely better than it was. I have absolutely no worries about this. And I'm going to go back and show you the log of how long it takes to find that spacebar, which is like our meme of this entire stupid exercise. My God, I spent a lot of time on that spacebar. Okay, here we go. And this time we can see, hey, he did that immediately. Like literally immediately. He stepped on the stairs, he breached. That's it. 0 keys. Here, he stepped on the stairs, he was locked for 3 steps. 3. In the past, we had hundreds. Stepped on the stairs, stairway lock broken, 0 steps. Hit the spacebar right away. So now, yep, 0 steps. So actually, he's basically getting down the stairs almost instantaneously. So this is starting to look already like a day, right? This is starting to look like a much more effectively decision-making CNN than what we had before with the other setup. And the fact is, this is a very serious learning for me. The kind of compression that we were doing before, I'm going to show you this again, what this was like before and after. Let me see if I can find it again. This kind of compression we did here is perfectly fine for literally just training an image recognition system. An image recognition system when you realize that you have massively highly high def photography or video, and you really need a lot less. And for every single one of these steps that you put in, you end up using like a quarter. You basically divide the amount of processing you take at least by 4, right? And so you're just trying to make it blurry so that you're not processing more information than you have to get the job done. But that is not what we want. We want to keep that information. And I think we're succeeding. I think that we're seeing that already, right? With this better information, with this better way of passing information through the model, we're seeing a much, much better result very quickly. And that's it. That's my update for today. I hope you found it interesting. I hope you found it helpful. This is actually an important piece of theory right here. So cool. Enjoy. Enjoy the rest of your day.